Have you ever come across the structure of the heart in your biology textbook and then you flipped over it as if though you saw a ghost? Because the structure to you looks so complicated and you do not even want to take a second look at it. Oh well, do not worry, you are the last bus stop. I assure you that just by the end of this lesson, you would be able to understand the basic anatomical structure and the pattern of blood flow in the heart. So without further ado, let's dive into today's lesson. So today we're going to be looking at the basic anatomical structure of the heart and get to understand the basic pattern of blood flow through the heart. Yet, in anatomy, you know we are looking at someone else's. Let's assume you are looking at my heart. This is my left, and then here is my right. So let's indicate that on the board in order for us not to get confused. So I have my left, and then I have my right. Now we'll begin by drawing the basic bottom chambers of the heart. So we have this, and then we have this. Yes, so these are the two basic bottom chambers of the heart known as the ventricles. So you can see we have, here is the left ventricle and then here is the right ventricle. Then you should know that the wall of the left ventricle has a thick layer of muscle. Okay, the wall of the muscle of the left ventricle is very thick. Yes. Why is this so? This is because it is from this part of the heart that blood flows into the systemic circulation, getting to the different places where blood is needed, such as the eyes, the ears, our lungs, and every part of our body. So you can see the distance that blood needs to be pushed in order to locate these various parts of our body, which is the reason why we need a thicker mass of muscle to be able to do that. But on the other hand, the wall of the right ventricle has a thin layer of muscle. So you can see a thin layer of muscle. A thin layer of muscle compared to the left ventricle. Why is this so? This is because this part of the heart only pumps blood to the lungs. So let's assume the heart is here and the lungs are just beside the heart. So you can see it doesn't take much distance. And therefore, the pressure needed to pump blood to the lungs, it's not so much as compared to this. Alright, the heart, we know, is a 4-chambered organ. Now let's begin to insert some arteries leaving the heart. At this point, there is a valve pointing upwards. And this valve is guiding a very big vessel. Okay, the valve guides a very big vessel, and this vessel is known as the aorta. Is known as the what? The aorta. Okay, and also just between the left ventricle and the upper chamber is another valve pointing downwards. The valve points downwards. Then also note that the upper part of the heart has a thinner muscular wall than the lower part of the heart. Okay, so we go like this and then we move, and as you can see, we are beginning to form another top chamber of the heart, which is known as the atria. And there are 4 large veins that drains into the left atria, but we usually indicate only 2 when we are drawing. So let's have it. So this is the first vein draining, and then the second vein draining, and they all meet at those points. So here is it. And those veins are called the pulmonary veins. They call what? The pulmonary veins. Why the name pulmonary? Pulmonary means anything that has to do with the lungs. And veins, we know, is a blood vessel that brings blood to the heart. So because those veins are transporting blood back into the heart from the lungs, therefore we have pulmonary meaning lungs, and then veins meaning back into the heart. All right, so this is it, the left ventricle. We have one valve here and another valve. Those valves which separate the left ventricle from the left atrium has two cusps. Okay, the cusp points down like this. Is that okay? And because of the two cusps, it's usually called the bicuspid. Bi means two. Okay, so we call it what? The bicuspid valve. Bicuspid. But the popular name is known as the mitral valve. The mitral valve. All right, then this other valve pointing upwards, which is guarding the aorta, is known as the aortic valve or the aortic semilunar valve because it looks like half moon. All right, so we have the what? The aortic valve. Aortic, or what we call aortic semilunar valve. All right, okay, now let's see what happens on the right side of the heart. So just very close to the aorta and the aortic semilunar valve, we have another valve which points upward, and this valve connects to a very big important artery. All right, and this artery divides at the top, each of them going to each of the lungs. This artery is known as the pulmonary artery. Okay, is known as the pulmonary artery. Pulmonary artery. Just like we have the pulmonary vein, okay, we know that artery is a blood vessel which takes blood away from the heart, and because this artery is taking blood to the lungs, we have pulmonary artery. Pulmonary meaning lungs. All right, okay, very close to this we have another valve which points downwards like this into the right ventricle. Okay, and as you can see, we are almost about to add the last chamber of the heart, which is the right atria. All right, so then this valve here which separates the right ventricle from the right atria has three cusps. Okay, just like we have here two, but this we have three, so it's like two here and then one at the below. Okay, they open up like that, and because of they are three in number, we refer to it as the tricuspid valve. While this valve which points up guarding the pulmonary artery is known as the pulmonary valve or the pulmonary semilunar valve. Okay, pulmonary semilunar valve. And finally, let's get to add the last chamber of the heart, which is the right atria. Is that okay? Then it is important to note that there are two large veins which empties into the right atria. Okay, they carry blood to the right atria, and these are the veins. We have this, and then we have this. All right, so these are the two large veins which empties into the what? The atria. The veins are divided into two. The one at the top, this one at the top drains blood from the upper part of the body and is known as the superior because it is at the top, and this one drains blood from the lower part of the body, is known as the inferior. But both of them are referred to as the vena cava. So that is the name of the vein, the vena cava. Vena cava. Right? So we have the superior vena cava and the inferior vena cava. So this is the basic anatomical structure of the heart. Let's quickly recap all we've been saying so far. We started by saying that the heart is a 4-chambered organ, and as you can see clearly, the chambers will have the left ventricle, the right ventricle, the left atria and the right atria. Okay, and then we also said that the wall of the left ventricle is much thicker than the wall of the right ventricle, because this is where blood is pumped to the rest part of our body. All right, and then we also made reference to the pulmonary veins, which brings blood back into the what, into the left atria. And then we have the aorta, which is the blood vessel leaving the heart, and then we also have this blood vessel known as the coronary artery, which also returns blood away from the heart into the lungs. And then for the valve, okay, this valve is known as the bicuspid or the mitral valve, where we have the aortic or the aortic semilunar valve. Then the valve guarding the pulmonary artery is known as the pulmonary valve, and also the valve separating the right ventricle from the right atria is known as the tricuspid valve. And then we also made reference that there are 2 large veins. Okay, they are the largest vein which drains into the right atria, known as the vena cava, divided into the superior and the inferior vena cava. All right, so the next thing we are going to see is the pattern of blood flow in the body. Blood coming from the lungs will be returned through these pulmonary veins. All right, and the blood is said to be oxygenated. Is that okay? So coming back from the lungs, the blood we have to return through the pulmonary veins and then empties into the what? Into the left atria. And when this chamber is full, it will mount pressure on this valve, which will now open, and then the blood will be pushed down into the left ventricle. In the same way, the left ventricle will contract, and when the left ventricle contracts, it then pushes blood away. It passes through the aortic valve or the aortic semilunar valve, and then the blood goes out to the systemic circulation, where it enters other smaller arteries, which distributes the blood. Then, as blood keeps going around the body, the amount of oxygen in the blood reduces, so there is need for the blood to be reoxygenated back. Okay, and then the blood has to be returned to the heart, where it will now be sent into the lungs to get oxygen, and then the flow of blood continues. So it is this vein that will return the blood back, all right, into the heart. So from the superior vena cava, it brings blood from the top part of the heart, and then the inferior vena cava drains blood from the bottom part of the heart, and then the blood empties. We usually represent the deoxygenated blood with blue color. All right, so the blood empties into the right atria, and from there the blood is pushed down to the right ventricle through the tricuspid valve into the right ventricle, and then the right ventricle contracts. It then pushes this blood, which passes through the what? The pulmonary vein or the pulmonary semilunar valve, and then the blood is sent across to the lungs, where it gets oxygenated. Okay, so that is the pattern of blood flow in the body, and we can say that the valves play a very important role in the flow of blood. It is important that those valves which guards the heart do not overexpand. Okay, the chief function of the valve is to ensure a one-way flow of blood into the heart. All right, so blood doesn't start flowing from here and then returns back. No, or for this bicuspid valve, okay, which is facing down, to now face up and enters into the atria. No, that will be a pathological condition, which is not good for the heart. So in order to ensure that this valve do not overexpand or expand backward, the valves are held strongly by a group of tendons. Yes, they are very strong tendons holding this valve in place. All right, yes, this group of tendons are known as the tendinous cords. All right, the tendinous cords, or most times you will see the Latin name as what? The chordae tendineae. The chordae tendineae. Okay, yes, And then these chordae tendonae, or the tendinous cord, are buried into the walls of the ventricle by a fibrous muscles. Okay, they are buried like this. You see, they are buried by a fibrous muscle called the papillary muscle. The what? The papillary muscle. Last but not the least, let's get to see the layers of the heart. All right, the heart is sitting in a thick sac. Surrounding the heart like this, okay, is a thick sac, very strong sac, which the heart is sitting round the heart like this. So the heart is sitting in this thick sac, and this sac gives the heart extra protection, yes, in addition to the sternum and the ribs and the vertebrae, in order for the heart not to over expand. You know, as blood is coming into the heart tends to expand, but it's important for the heart not to over expand. All right, so it is this fibrous tough sac that helps to keep the heart in check, and this muscle is referred to as the pericardium. Peri means perimeter, round, right? Okay, and also in the same manner, we have a thin layer of muscle which also lines the inner wall of the heart. Okay, this thin muscle also what? Lines the inner wall of the heart like this, in order to ensure smooth flow of blood. You know, as the heart is working, heart doesn't experience some turbulence. You know, you can just say and you hear your heart making some kind of movement. So it is the work of this thin layer of muscle to ensure that that doesn't happen. And this muscle is referred to as the endocardium. All right, endo means inside and cardium for the heart. Is that all right? Okay, then you can see the space, the remaining space surrounding this heart is enclosed by what? Bands of muscles. Yes, all through this space, okay, it's enclosed by what? Bands of muscles which are arranged round the heart. Okay, it surrounds the heart like this, and these bands of muscles helps to make sure that the heart pumps blood in the most optimum possible way. Okay, so these muscles are referred to as the cardiac muscles. You've heard of the cardiac muscle, right? But we popularly call it the myocardium. All right, we call it the what? The myocardium. Myo stands for muscles of the heart. All right, and finally, I need you to take a good look at this diagram. You see that the heart is divided into two, the left and the right, and the muscle which divides the heart into two is known as the septum. Muscle. Okay, yes. So that brings us to the end of today's lesson. I trust you got so much value from today's class, and you wouldn't want to miss whenever I publish a video. Please kindly do well by subscribing to this channel and hit the notification bell so that you get to know whenever I publish a video, because trust me, it's going to be fun and value packed at the same time. All right, until I see you in my next video, it is a bye.